Okay, we're looking at modeling up this full assembly here. First of all, we're going to start with a sub-assembly, which is going to be the roller, and go from there. So we'll start a new file, new assembly this time. And what we're going to do here is we're going to take in the components we need. So we can browse the new components here, and we're going to take in the two shafts that we need. So we're going to take in an end shaft. Just hit enter. We insert another component, and this time we're going to take in the roller that we've drawn. So we don't have to rotate or anything, we're going straight into the mate. So the first part's in, and we notice there's an F in front of the part, which means the part's fixed, so it's really our reference part. So now we can mate the cylinder and the cylinder. Fine. And then we want to get our depth here. So we have this part already prepared with chamfer for welding, so we're just going to do the flat face at the end, spin around the stub shaft and pick the flat face there as well, and we're going to hit OK, and we can see now that they're butted up against each other with a bevel prepped for welding. So that's the mates completed for those two components. We're going to take in the other shaft after drawing a minute ago, so we insert components and we'll hit browse, or we can pick them off the list. This list here will be the open parts you've opened, so you might see the part appearing there. So we'll use that part there. It's grey at the moment. We'll use our mate again, and again cylinder to cylinder, and we'll hit OK, and then flat face here at the back to the flat face of the roller, and OK. Now the keyway we have modeled in that shaft needs to be it's free to rotate at the minute, which mightn't be ideal, so we want to pin that down. So the best way to do that is to reference, if I just close off the mates there for example, we can reference the original part that we brought in, and we can see that the not that front plane, this top plane for example, let's go through the component. We're going to reference that with a plane on this part. So we hit our mate, that pre-selected, so we have that selected top plane, and if we expand down here, we can see our third part that we brought in, the grey shaft, and we'll go down here to see this front plane, and that would give us a reference. Okay, now the keyway is underneath, or maybe 90 degrees to what we want, so we could make that perpendicular instead of parallel, and it brings the keyway to the top. So it's defined where it is, which is better to have it defined than not defined. So that's a quick modeling of the shaft, so of the roller. So I can save that as a new assembly. So I'm just going to call that 50B in what I'm doing, and save it, the component. All right, so save again. So I'm going to create another new assembly here. So a new part and a new assembly. And I'm going to take in all the components that I want. So again, I'm going to hit browse, and I'm going to take in a base plate here. So it's a good idea to take in a base plate as the reference part and hit enter. It doesn't move. Okay, and we can see now we can use its work planes as the work planes for referencing. So our base plate, we're going to take our second part in. So what we can do is we can insert components and hit browse, and we can take in our bearing sub-assembly that we've done previously. Jump back and look at that. So it's the same basic kind of make commands we'd have done before. We downloaded our bearing in class. So this sub-assembly then can be mated. So again, we can mate the face to the bottom face, and then we're going to mate the holes. Doesn't matter whether it's the bottom of the hole or the counter bore. The same thing to these threaded holes, and hit OK. And we'll do the same up here. We can do bore to bore and hit OK. So at least you know that they're fitting correctly. So that's that sub-assembly done. You can take that sub-assembly in again, or we could mirror it across either, which might be an interesting thing to do. So because I know these holes are symmetrical, I could mirror that across. So if I use the base plate I took in, the plane down the middle of the base plate should allow us to mirror. We could pattern as well, but if we know that these holes are equal, we don't have to do that. So we can mirror the sub-assembly, the complete sub-assembly, and if we just hit the next there, we'll see the mirror command, what's happening. So the circlip is coming to the outside, and that's what we want to see, okay, rather than the inside. So that's it mirrored like that. Now we can go and take in our roller that we're after doing. Not that part, no, this one here. So we take in our roller, And again, we will go with our mates. We'll do shaft to bearing. That's okay, it's the wrong direction, but we'll flip it now in a second. What we might do then is we'll put the shoulder of the bearing of the shaft up against the shoulder of the bearing. And now we're going to flip it using the flip mate command. Hit OK. And I'm going to hit OK. And now we can see that this here should be lined up as well. We can see there's probably a larger distance here than the other side, so we might go in and edit that. So let's check out what that distance is first and then go back and edit it. So I might just save that quickly again as a part number, and what I'm going to do here is I'm going to create a new drawing and use the drawing to aid me in my design. So again, if I go to my view palette, I can go to my assembly here, of the unit, and if I take a plan view here just really quickly, okay, and I'm going to do just a quick section view through the plan view just to help me lay out the part, and hit OK. And if I zoom in on this section view here, I can quickly see that I butted this shoulder up against the bearing, but over on the other side there's a bit of a gap, it's free to float. So I can check what size that is. It's 2 millimeters there. It's easy to check it there. So I'm going to go back and edit the mate and balance that out. So if I go back into my assembly, where do I find that mate? I can find that mate if I close up all my parts here for a second. I can find it in the mate folder. But if I go to the roller assembly and expand it, I can see there's 2 mates in it. So it's not the concentric, it's the coinciding mate. I can edit feature, and instead of being coinciding, I can force it to be a dimension and make it 1 millimeter. So it's shifted 1 millimeter to the right. So hit OK with that. I can save that, and I can just go back real quick and check that on the 2D view I have. Now it's gone to 1 millimeter space over here, and over the other side we have the 1 millimeter from the offset from the mate. So that's good to go. All right. So we're pretty good with that at the moment. What we want to look at is this is free to rotate. That's fine. We'll leave it free to rotate for the minute. It's the whole roller that's rotating. What we want to add now is maybe the keyway, the key itself, and the gear at the end of this. So just to be clear there, I'm going to open up this part, right click, open part. I'm just going to change the color of that part just so I can see it versus the gear when I bring the gear in. So I save that, and I go back into my assembly here, just to have it orange so we can see it. So what I can do on the SolidWorks here is I can use the toolbox in SolidWorks, and what we can do here is we can do a few things. First of all, we'll take in the gear, and now we'll take in the nuts and bolts that we need. So we can go to DIN standards, power transmission, and gears, and it's a spur gear we want to take in. So we'll drag in the spur gear, and what we'll do is we'll pick up a module of the gear, maybe a 1.5 down to 1.5, and we can do the number of teeth. We can do 24, and what we want to do is we can leave face width. Okay, the shaft diameter then is going to be to match what we have, which is 16, and we can put in a keyway, a square 1 keyway on the 16 millimeter shaft. So that's the gear kind of defined here. We can always go back and edit that, and we'll hit OK, and we're going to place the gear then. We're going to just hit escape on the keyboard. We're just going to mate this gear manually, which is sometimes the handiest thing to do. Okay, so we'll do our mate again, cylinder to cylinder. Okay, we're going to drag that, left click the part and drag it forward so I can see it. Jump in here and cylinder to face, and hit OK. The next thing I want to do is I want to line the keyway up on the gear on the shaft. So if I pick the face and the face, I'm just going to make them parallel, not coinciding, because if I open up the keyway and make it slightly larger, but 0.1, it won't be coinciding. So I'm going to just make it parallel. And hit OK, and hit OK with that. So that's kind of the gear put into place. Okay, again, you can use any side of gear, but just for completeness, we want to put maybe the key in. So I'm going to right click on that, and I'm going to just hide the part. So you can see it hid here on the list. I can turn it back on a second because I want to just put a key in there. So what I'm going to do is just going to double check the size of that. And hopefully we'll get a key here to match. So in the DIN standards as well, we have a key and parallel key, and a 6885 is the standard. And we'll just drag that in. Okay, and it's a shaft diameter 12 to 17, and its length is 12, which should be okay, and hit OK with that. We had it loaded up before. Hit escape, and I'm manually going to mate this in. So I mate from the bottom face to the bottom face. Hit OK, and then I can just do the back curve semicircle to this semicircle. Okay, and again I need to do the front as well, semicircle to semicircle, and that will keep the key aligned, okay, and nice and square. So that key is pretty good. I can go back to my model and spur gear, right click on it and hit the eyeball for show components. So that's the key done. The last thing we're going to do is finish off with a circlip. We've done the circlips before for these other assemblies, but we're going to do another circlip. So again, our retaining ring into our German standard again, and we should see retaining rings, external retaining ring, and a circlip normal is usually fine, and it's a diameter of 16 shaft. You'll see that yourself. The size comes up here on the groove width and thickness, etc., that you can use. So I can hit OK with that. I can hit escape, and I can manually mate this in. So I'm just going to mate in the back face of the groove with the back of the circlip, and then I'm going to mate in the inside circle with any cylinder on the shaft. That's the retaining ring in place. Okay, we can download we can add to that again by using our bolts. Okay, so we can change from DIN to ISO standard for our bolts and screws, and we're using hexagon socket screws here, and just the kind of a hexagon socket head, and we'll think these are M6, and the length is 16 here on that. We're going to go with that. Again, we can update them if we're wrong, but we'll hit OK with that. I will just place them in. They'll drop in automatically using the reference mate. I'll go back and delete that first one in a few moments. Use the reference mate and use the reference mate. Okay, and that's the 4 bolts in as such. Hit escape on the keyboard and just pick that original one and hit delete on the keyboard as well. So if the bolts in there, I can check. If they're not long enough, I can make them longer, take them in again and replace them if I wish. So for example, if I wanted to do that, they're only 16 millimeters long. What I can do is I can take them back in again and change it from 16 millimeters long to 20 millimeters long and hit OK. So that kind of loads that faster into memory on the assembly, and that means I can go to these each individual fasteners and change them from 16 long to 20 long and hit OK. And the same over here, select the fastener and change it from 16 to 20 long and hit OK. If I had a pattern, I'd only have to do it once, so that's an advantage of having a pattern if you're changing something. And again, select this version and make it 20 long. And then delete these ones we brought in from memory. So that's kind of that assembly done. There's wee legs too we downloaded. They're up in Moodle. I'll import them really quick. They're just wee pads or wee feet. These were them here, I think. So we downloaded them from Izumi. They're up in Moodle. Again, they're a quick mate the bottom face with the bottom of the plate and the cylinder with the cylinder. Okay. If we do know the size of the distance between the holes, we can pattern these. So I might just pattern them really quickly. So I can select that hole and select that hole to get the distance between them there, and just hit evaluate, measure, and I see that there's 320 between them in that x-axis if you like. And again, select the cylinder hole control and select the other cylinder and go up and hit measure. So 320 by 120. So let's pattern that instead of maybe putting it in 4 times. So I go to assembly, linear pattern. My direction 1 is across the edge across the front, which is going to be 320, and it's going to be 2 of them. My direction 2 is up this way, and it's going to be it's going to be 120.